Radiation comes in from the sun, it heats the surface. Balancing radiation goes out from the surface and the infrared out to space. Or some of it's blocked, as we've seen already, blocked by clouds on the way, by gases on the way, greenhouse gases. Acting like a blanket over the Earth's surface, absorbing radiation, keeping it warmer than it would otherwise be. If we didn't have those gases there, the Earth's surface would be at a temperature of minus 15 on average, or thereabouts. We'd all be covered by ice, and it would be a very different world. The greenhouse effect has been known for over 200 years, and there is no doubt whatever that it's happening. Carbon dioxide is rising. That's the last 10,000 years of carbon dioxide. The last 200 years is the spike on the right, which is heading for the ceiling, and it's going to get above the ceiling very soon if we don't do something about it. So what happens if you double CO2 into the atmosphere? Just look at these various blocks on this diagram. You have radiation of 240 watts a square metre coming in from the sun on average, radiation of 240 watts per square metre going out on average in the long wave. Average temperature of the Earth's surface around 15. If you double CO2 instantaneously, thought experiment, the long wave radiation goes down because the radiation comes from higher in the atmosphere and you lose 4 watts a square metre. If you're going to get that balance back, which you need to do, of course, to bring it back into equilibrium, you can do that by warming the temperature of the surface and the lower atmosphere by 1¼ degrees, and the balance will return. So, if everything warms up by that amount, then you're back where you started from, except that that's if everything else remains the same. But everything else doesn't remain the same. You have these feedbacks, and if you allow for all those feedbacks, then the feedbacks roughly multiply it by 2, or rather more than 2, and you get about 3 degrees warming of the, or average warming of the Earth's surface as a result of doubling carbon dioxide. That's a very simple enhanced greenhouse effect, very simply how it happens, and that seems to be, that 3 degrees seems to be a very good number. Over the last, these are the temperature of the atmosphere, average temperature of the atmosphere over the 20th century. The red lines, the observed line, the black line rather, is the observed increase in temperature over the 20th century. A very substantial increase in the latter part of the century because of this, the increase of greenhouse gases. Simulated, the red line is a simulation by computer simulation showing we can really simulate that all rather well, allowing for volcanoes, allowing for changes in the sun, allowing for dust in the atmosphere, allowing for all the things we need to allow for. We can actually reconstruct that temperature profile really very well. And when people say we don't understand it, you know, because the climate is very variable, it has a lot of variability, which is sort of the fuzzy area around is natural sort of variability, which is going on all the time. But the general trends we can actually simulate very well indeed. The right-hand diagram is the same computation done. The blue line there is if you leave the greenhouse gases out, the increase in carbon dioxide and other greenhouse gases out, the simulation, you can't simulate the last 30, 40 years at all. And that's a really very good demonstration of how good the computers now are at simulating what is going to go on and giving us some confidence that we can actually predict for the future. So by the 2050s, the temperature will go up a bit like that, land warming much more than the oceans, and because the oceans take a long time to warm up, and you're talking of about 4 or 5 degrees over the land but in that sort of time, and that's an enormous change in the average temperature. It's a bigger change than the Earth has seen for at least 10,000 years. And the big problem is we're going to find it very hard to adapt to that rate of change, either as human beings or as ecosystems on the Earth. Very hard indeed. A few words about the IPCC, which I was privileged to chair or co-chair the Science Working Group from in 1988 until 2002, the first 3 reports. We tried to involve all the scientists in the world we could find because it's a world business. We argued loud and long. We had some very, very heated arguments. We had very good arguments. It was enormous fun. We all enjoyed it. We all learned so much from each other. People from different disciplines got together and really tried to tell our very best possible story about what was happening to the climate. And people say we were distorted by political interference. There was a lot of attempted political interference, but we believe we maintained our integrity throughout. And some of the political interference actually made us better, because it made us more accurate. And if you want to say, what does the world scientific community itself think about it, which is the wider world scientific community, represented by the academies of science, these are the top scientific bodies, not green people, not environmentalists, the best scientists in the world, from all the major countries, in 2005 issued a joint statement saying, look here, O nations, this was before the G8 summit. They said, look here, O nations, please, this is already happening. You've got to do something about it. We are the world's top scientific bodies. We've got together on this. We don't get together on very much at all. We hardly ever publish joint statements. We're really trying to send a message to you. And incidentally, if you want to learn more about it, go to the reports of the IPCC. And they've issued similar reports of it since that date. And yet there are still people in the world who try to tell us that the scientists aren't agreed, that it's all very uncertain, and the scientists don't know what they're doing, and they're all really greenies, and crazy individuals like me actually wrote these summaries, and when they were actually agreed in big meetings of government people, from 100 countries, all going through it sentence by sentence. That's the degree of scrutiny we had with those documents. And there's a lot of rubbish about the IPCC on the internet, awful lot of absolute nonsense, which has been put there by people trying to kill us and trying to spread misinformation because of their own vested interests. And it's still going on. So there are the 4 reports. These are volumes you may, if you haven't seen it, get hold of an IPCC volume and look at it. 1,000 pages, roughly speaking. They are A4 size. If you go to the website, the IPCC website, if you have the time and the patience and the paper and the ink, you can download them all. That's the working session, the last session I was involved with in Shanghai in 2001, which is a super meeting we had. That's an article in Nature which produced that cartoon. There's the Earth and its temperature being taken by these crazy scientists in the IPCC. But Berlin is on the left, and they're trying to calm the Earth down. Gilman Myra, who is my co-chair, has the thermometer in his hands, and we had a very tough meeting in Madrid, and that's a cartoon of that meeting. And then, remarkably, the IPCC got the Nobel Prize, Peace Prize, in 2007. There's the group from Working Group 1 who went there to receive it, and there were the other working groups as well. Susan Solomon, who is the present chairman, or the chairman for the last report, is in the middle there. Dai Quinn from China was her co-chair. Bob Watson, who was chair of the whole IPCC, is the man with the beard behind. And there were other, Dan Orbiton and what's his name? Richard Wood, that's what I was just trying to remember his name. Is the other person there who represented the Working Group 1 at that. And there's the whole group of us. Al Gore also got a Nobel Peace Prize for his work on the climate. And there you have Pachauri, President Pachauri, who is the chairman of the IPCC, and Al Gore and a whole lot of people who, the delegation we took to Oslo to get it. Well, what are the main impacts of this climate change which is occurring? Very quickly, let me go. It's all very well talking about global average temperature. Let me try and talk a bit about very quickly about the average impacts. And this is heat waves. 2003, there was this very pronounced heat wave in Europe, which is very unusual. Way outside, you see there's the average temperature in central Switzerland in all the years from 1864 till 2002 in blue, and 2003 is 5 standard deviations away from the average. So a completely unusual event. And people have studied it and say 70% of the risk